Hey guys, welcome back and let's learn BGP route reflectors. So by the end of this topic, you should be able to understand what BGP route reflectors are and why do we need BGP route reflectors in our BGP network. Should also be in a position to configure BGP route reflectors. So to ensure connectivity between the IBGPs, you need to establish a full mesh connection between IBGP peers. So let's say you have got the connections. When you have n number of devices in your autonomous system, the number of IBGP peer connection that will be established will be n into bracket n minus 1 plus the bracket divided by 2. So for instance, let's say if there are so many number of devices in your network, so many connection will be established, and this one will use network resources, and also the CPU resources will be consumed highly. So to cap this problem, that's why we need to configure what route reflector called route reflectors in our network. So we will configure route reflector to help cap this problem, to also minimize the CPU usage and also the network usage, and also limits the number of connections that are established in your BGP network. So there are terms here that we also need to understand. So the terms here are route reflectors. Route reflector abbreviated as RR. So a route reflectors here is a route reflector is a BGP device that reflects IBGP routes from IBGP peer to other peers in a BGP network. BGP network. Like for instance, here in this our topology, let's say switch. See, here is our route reflector, as we will use it as our route reflector here. It will reflect the IBGP routes for switch B to IBGP peer switch D. So there are two pairs here, so switch B and switch D. So this route reflector here, it will reflect the routes from switch B to switch D. Then another thing, we have got what is called the client. So client, like switch B, will act as the client. So switch B is a device IBGP device whose routes are reflected. Device, it's an IBGP device whose routes are reflected by route reflector. Whose routes are reflected by route reflectors to other IBGP peers. Like for instance, here switch B and switch D are clients, so they are clients. Then after switch, then we have got something also called non-route reflectors. So non-clients, so there's something called non-clients. Non-clients here are neither route reflectors nor nor clients. They are neither route reflectors nor clients, but they establish full mesh connection with the route reflectors. So if it's not a client, it is a non-client, but it will have to establish a full mesh connection with the route reflector here. So maybe if you had a device and connect to the route reflector, but it is not a client, that one will act as the non-client. Then we have what is called cluster. Cluster is a set of route reflector and a client. So cluster just composed. When I say a set, it just means that it composed over a route reflector and also a client. So set of route reflector and a client. Cluster ID is an attribute that helps eliminate routing loops between the clusters. Eliminates cluster ID attribute. Cluster ID attribute. Cluster ID attribute eliminates routing loop. Eliminates routing loops between clusters. Eliminate routing loops between clusters. Then lastly, we have got what is called the fourth one. Now here will be the fourth term here is called originator. The role of originator is just originates routes, originates BGP routes. Originator here just originate BGP routes. So originator ID. Originator ID is an attribute. That eliminate loops within a cluster. Attribute that helps eliminate loops in a loops in a cluster. Routing loops. Helps eliminate routing loops in a cluster. So these are the most important terms that you have to understand in a BGP when we talk about BGP reflectors and when you want to configure BGP reflectors. You have to understand what route reflector is, client, and also it's important also to understand non-client, cluster, and also originator. To begin, we are going to configure the IBGP, and also we are going to see how you can configure the BGP route reflectors. So let's look and see the requirement. So the networking requirement here is that 4 switches belong to switch A and switch B establish an exterior border gateway protocol neighbor relationship, and switch C establishes an IBGP neighbor relationship with switch B and switch D. To prevent IBGP fully meshed connections and simplify network configuration, the user requires that devices in 2 autonomous systems communicate a bit when no IBGP connection is established between switch B and switch D. So there is no IBGP connection established between switch B and switch D here. And then the roadmap here is configure basic BGP functions to allow BGP neighbors to communicate. Configure switch C as the route reflector and configure switch B and switch D as 2 clients of the route reflector. Subsequently, switch B and switch D can learn the routes advertised by switch A without establishing an IBGP connection, simplifying configurations. So that is the networking requirement. Now we go to our task and we are going to configure layer 2 and also assigning IP addresses to the interfaces, the VLAN if interfaces. So here we are not going to configure all the interfaces, but we are going to configure switch A here because the configuration for switch B, switch C, and switch D are the same as the configuration for switch. So switch A here I'm going to use just as a demonstration to show you how you can configure the interfaces and give IP addresses. Then switch B and switch C, they will just replicate from what is configured on switch A. So let's configure this route reflector very fast. So we enter that device, we are going to create the layer 2 and also the IP addresses. So I'll do terminal. We are going to change the device name to switch 1. So this switch A. On switch A, we are going to create a VLAN 10. So VLAN batch 10, and enter the interface VLAN and give it IP address interface VLAN if 10. Give it the IP address of 10.10.10.01/24. Then we also create the loopback interface and give it an IP address. So interface loopback 0, give it the IP address of 192.168.10.1/24. Quit and configure layer 2. Layer 2 here going to be interface VLAN if, not VLAN if, interface gigabit, interface gig 0/0/1. Tell it port link type, trunk, this is a trunk port. Then port trunk, tell it to allow pass, port trunk allow pass VLAN 10. After tell it to allow pass, you enter gig 2. Also tell it port link type trunk. Then you tell to allow service from VLAN 10 to pass. Control Z and save your configuration. Save. Yes. After configuring the layer 2, let's check with these other guys if their interfaces are up. So display CU. So you see they have IP addresses. They have been given IP addresses. Actually, I left for switch 1 so that I could show you how you can configure, just a demo how you can configure interfaces. But the same thing happens with switch C and switch B and switch D. Just the same things as you configure interface on switch 1 as how you configure on switch B and switch other switches. The next thing is now to create IBGP. You're going to create IBGP. So on switch 1 here is on autonomous system 100. So BGP 100. Router ID here we were given of 10.1. So router ID of 10.1.1.1. The peer is going to be 10.10.10.2. S number, autonomous system number will be 200. It's going to create IBGP here with autonomous 200. After that you are going to advertise the network for the loopback and also for that VLAN 10. So IPv4 family unicast, then network of advertise the network of 192.168.10.0 vulgar mask of 24. Also advertise the network of 10.10.10.0 vulgar mask of 24. Save and you go and also configure the IBGP on switch B. So this one is going to be BGP 200. Router ID here is router ID is 10.2.2.2. Then peer is going to create a peer with 10.10.10.1. The S number here is on autonomous system 100. Autonomous will be 100. Then you also create a peer with switch C. So a peer, create a peer with 10.10.20.2. AS here, autonomous system number here is 200. That is going to create IBGP with switch C. As you can see, the status have changed from up to open, confirm to established. Those are the BGP message states. Now after that, the next thing you configure is to advertise .NET network. So IP v4 family unicast. On IP family unicast, you're going to address the network of 10.10.10.0/24, and the next network will be 10.10.20.0/24. Quit, and the next net we quit and we save. Do the same to switch C. Switch C also you configure the IBGP. It's going to create IBGP peer with switch B and switch D. So create BGP 100, not 100, 200 for this case. On BGP 200 we create a peer with switch B. So peer 10.10.10.1. Autonomous system number here will be 200. It is going to create IBGP. Then we go to the next peer with switch D. Peer will be 10.10. Sorry. The peer will be BGP. Peer with switch B was 10.10.20.1. Then the next one will be 10.20.30.2. Then you advertise that network. So okay, give it router ID of 10.4.4.4. Remove the router ID. So that parameters display. Also, after that, you advertise the network. So IP version 4, PV4 family, unicast. That's the network of 10.10.20.0/24 and the network of 10.10.30.0/24. Save and you quit. On switch D also you do the same. BGP is here is 200. On BGP 200, route ID here will be let's give this 10.3 because it has interchanged with the route ID for switch C. So 10.3, for this case 10.3.3.3. It's going to create a pair with switch C. So here 10.10.30.1. Autonomous system number here is 200. So after that, you advertise that network. So the network we want to advertise is a network of 10.10.30.0/24. Then we save. After that, we're going to configure now the route reflector on switch C here. So switch C here is where we are going to configure the route reflector. So enter BGP 200. On BGP 200, configure route reflector. So here 10.10.20.1 reflect client. Then we also configure peer 10.10.30.2 route reflect client. Then you save your configurations and see. Now we are going to try and see if display BGP routing table 192.168.10.1. That is for the loopback. So the local route ID here is 10.4.4. The AS number is 200. So one path available and one best path. So this is the RR client from address 10.1 10.10.20.1. So after that, we try also on this route D here. So display BGP routing table 192.168.10 and see if it knows about that guy. So also you can see here local route ID is 10.3.3. paths, one path available, one best path selected, and it is from the route is from 10.10.3.0.1 And our next hop will be 10.10.10.30.1. Then the outbound interface will be VLAN if 30. Next hop will be 10.10.10.1. Now let's try to ping that network. So ping 192.168.10.1. You can see we can reach that our loopback 0, that is on a different autonomous system. So that's how you can configure route reflectors, guys, and I hope you understand what we've tried to explain here. And in case you have a question, just hit me in the comment section and I'll respond to you as soon as possible. So thank you, and let's meet in our next videos.